Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about properties of logarithms. So there are really three properties that I want to go through. Very straightforward. Then the application requires some experience and for you to work on the properties in actual practice problems. So we're going to do some of those as well in this lesson. Then we'll do some more in the practice session of applying properties of logs in another video. All right, so properties of logs. First thing is b, m, and n are all positive numbers, and b cannot equal 1. All right, so just take that into consideration, b, m, and n. So I have base b of m times n. M and n are positive numbers. B cannot be equal to 1. All right, so the product property says log base b of m times n is equal to log base b of m plus the log base b of n. So let's take an example, and we'll go through a couple more examples as we go through this lesson. So let's say log base b of 24, and we'll make b equal to, let's say b is equal to 7. Let's get a smaller eraser here. So log base 7 of 24 is equal to log base 7. So we keep the same base. And now a product of 24, we could use several different factors of 24, but we'll just use these as an example. Log base 7 of 8 plus log base 7 of 3. So we can take the factors of 24, keeping the base the same, and now we're adding the two logs with the same base, but using the different factors of the original log expression. All right, quotient property of logs, log base b of m divided by n is equal to log base b of m minus log base b of n. So if I had something, another example, let's say log base 5 of 17 over 5, that would be the same as log base 5 of 17 minus log base 5 of 5. Now I can simplify this last portion of the expression because I know the log base 5 of 5 is going to be just 1. So I would rewrite this as log base 5 of 17 minus 1. Okay, power property, log base b of m to the n is equal to n times log base b of m. And so in this case, we're just taking the power of m and we're applying it to the log base b of m, multiplying log base b of m times n. So an example might be log base 3 of 7 squared. So now we're going to take the exponent for 7 and we're going to move it in front of the log and multiply the entire log, including just the 7 and not including the squared portion. So this ends up being 2 log base 3 of 7. Right, so one of the problems that my students run into is making sure that when they rewrite these problems that these values stay on the same line. So 2, 7, log are on the same line. 3 is like a subscript of the log. All right, so if I were to draw these lines here, log and 24, 7 is a subscript. Log 8, same line as log, and 3, 7 as a subscript. Again, 17 over 5, same line as the log. Log base 7, 17 minus 1, 17 and 1 are on the same line. So be careful as you write the log expressions not to bounce the values all over the place because it will get confusing for you and you might twist your brain in knots trying to figure out what you're doing if you don't rewrite the equations properly. Now, in this case, 2 is an exponent of 7, so it's obviously not going to be on the same line as the 7 or the log. All right, so let's move on. Let's take a look at each of these properties in a little bit more detail. So the product property, I'm going to give you an example. I have log base 5 of 625. I can separate that into log base 5 of 125 plus log base 5 of 5 if I wanted to. And I get log base 5 of 125 is equal to 3. Remember, if you were to rewrite this log expression in exponential form, it would say log to some value is equal to, 5 to some value is equal to 125. So 5 risen to some power is equal to 125. And we see that that value ends up being 3. log base 5 of 5, as we know, is equal to 1. 5 to the 1 is equal to 5. I add these two values together, I get 4. All right, and this one I have log base 3 of 72 is equal to some value. Now I can rewrite this as log base 3, and the first application is not so helpful because I know 5 to the 4th is 625. We don't need to separate the factors. But in this case, we're going to want to separate the factors out because I have log base 3 of 9 plus log base 3 of 8. Remember, 9, log, and 8 are all on the same line. Log base 3 of 9 is equal to 2, right? 3 squared is equal to 9, plus log base 3 of 8. So you want to simplify these values when you can get a whole number, an integer, out of the expression. So that's what we've done in this case. In this case, we will not get a whole number or an integer value out of this expression, log base 3 of 8. So we just leave it as it is, log base 3 of 8. All right, moving on to the second property, quotient property, log base b of m divided by n is equal to log base b of m minus log base b of n. And I give an example here, log base 36 of 1 over 6. And again, be careful about those lines, right? 1/6 on the same line as a log. That's the same as log base 36 of 1 minus log base 36 of 6. And I end up with, if you ever see this 1 here, log base, anything of 1, you know that the value is going to be 0. So 36 to the 0 is equal to 1. That's 0 minus log base 36 to the 6. That's actually the square root of 36 gives me 6. So 36 to the 1/2 is equal to 6. So I end up with 0 minus 1/2, and that's your ending value. Okay, the second log is going to be log base 6 of 5 over 8, and I can rewrite that as log base 6 of 5 minus log base 6 of 8. Really can't do anything with either of these, so I'm just going to leave them as it stands, and then move on to the power property. So actually, let me just clarify. I had previously said you want an integer result. You can also get a fraction result. Then you are fine in simplifying this particular expression. Okay, so third property is the power property. I have log base b of m to the n is equal to n times log base b of m. Remember, n, log, and m are on the same line. B is a subscript. So I have log base 4 of 49. I simplify that to log base 4 of 7 squared, which gives me 2 log base 4 of 7. All right. In this particular example, I have log base 8 of 4. Now, there are a couple different ways to solve this problem, but I'm just going to use this property, the power property, just to show you how it works. So I have log base 8 of 2 squared, which leaves me with 2 log base 8 of 2. Now I can simplify log base 8 of 2 into a fraction, right? Because I know that log base 8 of 2, in fact, I can simplify both of these into a fraction. I know that log base 8 of 2, I can take the cubed root of 8, and I get 2. So this particular portion of the expression can be simplified to 1/3. So I have 2 times 1/3, or 2/3 as my result. And then the next expression, I have log base 7 of 81. Log base 7 of 9 squared gives me 2 times log base 7 of 9. Okay, so let's talk about expanding and condensing expressions. So I have properties of logs. When I expand, I'm separating the factors in the product property. Right, so expanding, separating the factors in the product property. In the quotient property, I'm separating the dividend and the divisor. So I have m and n, and then condensing, I'm combining them into one fraction. Combining in the product property gives me the product of the two factors. Expanding in the power property places the exponent of m in front of the log, and then condensing, expanding places the n in front of the log, and condensing places the exponent to the m value. All right, so in expanding, we'll go through some of these problems that we just went through. So expanding, I'm expanding in this direction, and then I'm condensing in this direction for the power property. Right? For the quotient property, I'm expanding to the right, and then I'm condensing when I move to the left. And then finally, the product property, I'm expanding or separating the factors out, condensing, combining them together into a single log. Right, so let's take a look at some problems using expanding expressions. So I have log base 3 of 4 times x, and that's the same as log. I'm going to expand log base 3 of 4 plus log base 3 of x. I have natural log of 12 over 5. That's the same as natural log of 12 minus the natural log of 5. Expanding this expression. So remember my power property. This is the same as 4 times log, it's a common log, so base of 10, so I'm not going to write it, log base 10 of 3 plus log base 10 of, I thought this power was applied to the entire value, so let me correct myself here. And I'm going to take this out, erase this, and I'm going to rewrite this as now 4 log base 10 of x. So I was looking at the problem very quickly thinking that this was what I was solving for. And if I were to solve for this particular problem, then I would have 4 times log base 10 of 3 plus log base 10 of x, all in parentheses. So you see the difference between the two versions that I've just highlighted for you. And I'm going to erase this back out so that I show you the correct answer for this particular problem. And then again, I have a log base 4 of x over 3 y, and that's going to give me log base 4 of x minus, and then we're going to put this in parentheses now, or some bracket, log base 4 of 3 plus log base 4 of y. So you see this particular entity or expression corresponds to 3y, right? And I'm subtracting, in my quotient property, I subtract that log from log base 4 of the numerator. Okay, so just to clarify what we're doing. All right, moving on, expanding the expression. So now we're getting a little bit more difficult. We want to expand this expression. So I have log base 7 of 5 plus 3 log base 7 of x plus log base 7 of y plus 2 log base 7 of z. So you see log base 7 of z, 2 log base 7 of z, log base 7 of y, 3 log base 7 of x, and then log base 7 of 5. Okay, so that's how we've taken care of expanding this particular expression. Okay, what else do we have? Condensing expressions. All right, so we talked about expanding. Now we're going to condense. I'm using my quotient property here. This ends up being log base. So remember, these bases have to be the same in this case. Log base 4 of 7 over 10. In this case, I have log, it's a common log, so log base 10 of x squared times 11. In this case, I'm using my quotient property, so I have natural log of 12 over 4, which is the natural log of 3. In this case, I'm again using my quotient property. I have common log of x to the 5th all over y to the 4th. I don't think I've done a good job of making sure that these look correct. These should be on this this fraction, excuse me, should be on the same, basically the same line as the log. So I'm going to rewrite it here. I have a log, the base 10 of x to the 5th over y to the 4th. So again, we have to be careful about how we write the log expressions so we don't add to any confusion that already exists in terms of solving for logs. Okay, one last problem as an example, then you get to graduate at least from this lesson. I have 2 times log base 3 of 20 minus log base 3 of 4. So let's just take this section here, and we're going to condense this expression. So I have log base 3 of 20 over 4 and I'm going to square that value. Okay, so let's simplify. 20 over 4 is equal to 5. 5 squared is equal to 25. So I can rewrite this as log base 3 of 25. All right. Now this portion over here, I can simplify 0.5 log base 3 of 4, right? It's the same as log base 3 of 4 to the 0.5, which is the same as log base 3 of 2, right? So I can, 4 to the 1/2 is the square root of 4. So I can rewrite this, at least this section here, as log base 3 of 2. And now I'm multiplying these two together, right? So I'm using my product property to condense these two expressions. So it ends up being 25 times 2. I have the same base here. So the result ends up being log base 3 of 50. Pretty tricky, huh? So this, remember, log and the 50 on the same line. Base is the subscript. It sits on or inside of the line, not on top of the line. Okay, so log base 3 of 50 is your answer. That's it for applying properties of logs. Come back and join us in doing some practice problems in the next edition of Autumn Math.